How are you everyone? Welcome to today's tutorial. And in this tutorial I'm going to show you how you can basically solve any number involving circuit diagrams. This is good for all of you going to do your ECE examinations. This number is always common there. They set it with some good questions. And I'm going to show you how simply you can do that number and come up with all the marks that you desire there. So watch out for the number. Now, before you start any number on a circuit diagram, there is some vital information that you need to know. Yes, for example, you know that we have this components called resistors. The resistors can be connected either in series or parallel. Let me assume that my resistances are R1 and R2. Assuming that these two are in series, the total resistance, we know that it will be, let me call it RS. This S means that I'm considering resistors in series. So the effective resistance in this case is always R1 plus R2. That is simple, isn't it? Very simple, you can see. And if they are not in series, we can also arrange them in parallel actually to give a minimum resistance. So this is RP is always R1 R2 over R1 plus R2. But remember, this applies to only two resistors in parallel. If our resistors are always more than 2, you know what we do? So I shall say that 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. That's if they are more than 2 resistors, but for simplicity, if they are just 2 resistors, yes, just come straight away and use this. We also can't forget this powerful equation, that V equals I R. Remember, we get this from Ohm's law. I hope you know that. And also, if we are doing a calculation involving the entire circuit, we know that E equals I into capital R plus small r. So let us define some key terms here. The V that we are talking about here is the PD, you can call it PD, potential difference of voltage. It is measured in volts. It is a capital V. This I we are seeing here is current. The current is always measured in amperes. Amperes is capital A. You know that, I think. This E means the EMF of the cell. If you talk about EMF, you are talking about the electromotive force of the cell. So think of this as the driving energy. When the cell is supplying current, the driving energy to move that column of charge in the entire circuit is what we call EMF. So it basically disturbs something to differentiate it from PD, but PD, remember, is that work done to move a column of charge across two particular points or across a particular component in a circuit. But when it comes to EMF, it involves the driving of that charge in the entire circuit. So it is also measured in volts. So we have this Mr. Capital R is always, you know, the external resistance, the components that they arrange there. The R, this capital R is the external resistance. Now, this Mr. here, small r, is also very important. Not even just important, but I can say important. Because if you ignore him, you can get some big trouble. So this small r, I call it the internal resistance. It is always within the cell. Sometimes it is given, sometimes it is negligible. If it is negligible, just put it as 0. But if it is not negligible, you have to treat it like this. So with all of this in our heads now, we can go ahead and look at our examples. Thank you. This is our question. It is a basic question, but we can use this to understand each and every concept that we can come across in electricity circuit diagrams. This information, remember, is very important if you're preparing to write your final exams of UCE, basically. But, so, they are saying that a battery of EMF 10 volts and negligible internal resistance. Now, this one is important. Negligible internal resistance. I think we are missing something here, but it's connected to resistors of resistances. We have 4 ohms, 6 ohms, then 2.6 ohms as shown. Now you can see the question. Now, our questions are here. Current through the 2.6 ohm resistor, and then the power dissipated. I forgot to talk about the power. But power, like we know, power is IV, but it can be modified depending on the parameters you're having. So it can be I squared R or V squared over R from our Ohm's law equation. So let us get started. The most important thing to start with, whenever you see a question like this, whether asked or not, first work on the resistances. So you can actually redraw this circuit diagram on your own. So we start with a cell, or it is a battery in this case. It has the positive terminal, which is always this long stick. You can see it is always the positive. The small one is the negative. So this is our positive terminal. Current is always flowing in a direction opposite to the direction of electrons or charge. So our current is always from the positive terminal of the cell. So if we closely follow the direction of current, we can say that it will be from this positive terminal. So we follow, this is our current, maybe it is I, current I. It comes like this, it comes like this. Now, when it comes here, we call this a junction. So this current is going to divide to pass through the 4 ohm resistor and the 6 ohm resistor. This means that now the 4 ohm resistor and the 6 ohm resistor are in parallel, because components in the parallel have different current passing through them. So the amount of current passing through the 4 ohm resistor is not the same current passing through the 6 ohm resistor. So our current in this case is going to divide. So let me call this one I1. Let me call this one I2. Because of this junction, it is dividing. So that current comes like this. Now it joins again at this point to form our I again. So it is I, which is the main current from the source, which is passing through the 2.6 ohm resistor. But like I told you, first things first. Whether asked or not, you can deal, or you have to first deal with the resistances. So first of all, we've identified the parallel combination in this circuit. So let us deal with that individually. So we shall come and say, now that we have the parallel, this is going to be the parallel resistance, parallel resistance. Let me call it RP. What do we know? We know that for the parallel, this RP will now be R1, R2 divided by R1 plus R2. As simple as that. So this one will give us the 4 times 6 over 4 plus 6. I guess we shall have 24 over 10. Those are 2.4 ohms. This is now the resistance across our parallel combination. This implies that now the effective resistance, I'm going to get this parallel combination and add with this other remaining resistor, which is the 2.6 ohm resistor. So we shall come and say here that now the effective resistance, Let me call it now R. So our R will be now this RP that we have got plus this other remaining resistor. Maybe we call it R3 in this case, because we call this one R1, R2, so we can now call this one R3. Therefore, it will be the 2.4 ohms, then plus the 2.6 ohms, and our answer will finally be, who can guess there? Yes, you guessed it right. It is 5 ohms. So, we now have the effective resistance in this circuit. Boys and girls, these marks here are free, because whether asked or not, I'm giving you a trick. You have to begin with dealing with the resistances. Identify the parallel, and then you add it to the remaining resistors. Now, let us now come to our question, asking for the current through the 2.6 ohm resistor. If we closely look at this one here, the 2.6 resistor is here, and the current passing through is the main current. In this case, they are now asking for the current in the main circuit. Quote me well. If they ask for the current passing through a resistor which is not in the parallel combination, they are always asking for the main current passing through the entire circuit. So the circuit equation now comes into play, because in order to find the main current, you need to consider everything in the circuit. Everything there has to be considered, like you see. Don't say that now our R is 2.6. No. The current passing through the 2.6 ohm resistor is the current in the main circuit. Get it right, boys and girls out there. So we shall come and say that from E equals I into R plus R. Our EMF, remember, they gave it as 10. So 10 equals, this means the I that we are looking for, into the R. Now the effective resistance, much as they're asking for the current through the 2.6 ohm resistor, but we consider the current through this resistor is the main current I. So we are considering the entire circuit. So this one is going to give us 5, then plus this one. I remember I told you to underline this word, negligible. It is approximately to 0. It is very small. So you can say now plus 0. That one there. So our I, like you can see, it will simply be 10 divided by this 5, and we shall have 2, not cats and dogs, but 2 amperes. Yes, very interesting there. So before we stop, let us now look at this other part. Power dissipated in the 6 ohm resistor. And you think you can copy down this before we start doing this one. Thank you. This means the question is saying that calculate the power dissipated in the 6 ohm resistor. Remember, power is the rate at which electrical energy is converted into other forms of energy. Now, the power dissipated in the 6 ohm resistor. Before, let me talk about power briefly. We know that power equals IV. Right? So, but from our V equals I, R, we can come up with something very small here. If I substitute for V in this equation, what will I get? I'll get that P equals I squared R. The V has been eliminated. I can also choose to eliminate I, because from this as well, my I will be V over R. So I can bring it here. My power will become V squared out of R. Now, these two formulae are very important when you're dealing with power. We have the IV, we have the I squared R, we have the V squared over R. Now, they're asking for the current dissipated in the 6 ohm resistor. In the 6 ohm resistor, if you're to talk about I, if you talk about I, if you want to use any of this or this, the I you have to be using, remember, it has to be I2. Clear there? It has to be I2, not I1 or this main I, because through the 6 ohm resistor, it is a current I2 which is passing there. So that is the case. For the sake of V, again, the PD across the 6 ohm resistor is the PD across the parallel combination. It is not this EMF of the cell, because the PD across the parallel is always different from this other component. So the 4 ohm and the 6 ohm have one thing in common, and that is the PD across them. We call it the parallel PD. So if I'm to use this or this, I'm saying that now for this particular question, if I'm to use this one, I have to have I2, then VP. Because it is the power through that 6 ohm resistor. Let me call it P, make a 6 ohm. You can see it there. Or, if I want to use this, it will be I2 squared R. Which R is this? We call it R2. You're seeing that? And if I want to use this one, V squared over R, I'm going to use, it will be VP squared over R2. This is how you interpret power depending on which resistor has been asked. This resistor, you can see, it is in the parallel combination. So if I'm talking about I, it has to be I2 because it is that I passing through that resistor. If it is the V, I have to consider only the PD across the parallel combination. So the choice is yours. Let me go through all of them briefly. So let me start by getting VP. Let me start by getting VP. By VP, I'm talking about the parallel PD. So parallel PD. Let me see. Parallel PD. Let me call it VP. So you can as well cram this, but it is not good to cram. So VP equals I RP. Yes, the I is the same because the current, when you combine this combination, this will gives you this I. So I RP is going to be our VP. So which I did we get? Was 2, and our RP was, I think, 2.4. So which answer we get there? I moved with my calculator. So calculator has jammed. So what is 2 times 2.4 there? Oh, sorry. So we are not getting the answer for that. But let me assume that it is 4 point something there. So let me assume that it is 4.8 volts. That is the VP. So I can now come and say that now power through the 6 ohm resistor is going to be the VP, which is 4.8. Sorry, VP squared over R2. So that one will give me 4.8 squared over the 6 ohm resistor. So the answer I get there is the power dissipated in that resistor can be in watts or joules per second, whatever it is. So the same can be applied when you want to use others. For example, if you want to use I2, to get I2, it is very simple. We know that VP equals I1 R1 also equaling to I2 R2. So this is what I want. I'll come and say that VP equals I2 R2. So that I can come and I get my I2, then use it in I2 squared R2. So thank you for watching my tutorial. Remember, my name is Grace. Remember to subscribe